Hey guys, sorry I couldn't be here today. Just going over 7-3, we're going to be able to write linear equations as functions. And if you recall back when we had our discussion on 7-1, how we compared my experience with narchies and oranges, it's the same thing we have here. A linear equation is an orange, a function is a narchie. Even though we call them different things, they have the same format, they're the same structure. So as we go through here, our first example, we need to review real quick from our previous units how to find slope. And so to find slope, well, here we have some points. And in A, we need to remember our slope formula. So m equals y2 minus y1 divided by x2 minus x1. So the second y that occurs minus the first y, the second x that occurs minus the first x. So let's do that. As we see here we have an x, we have a y, we have an x and a y, and we need to know the difference between them. So this one here is the first x that occurs. This one next to it is the first y that occurs. This is the first x that occurs, and the second one is the second x that occurs, and this is the second y that occurs. So now we plug that information in. We have negative 8, because that's y2, minus y1, which is 4. And then from there, we divide that by x2, which is 6, minus x1, which is 3. And as we simplify that, we get negative 12 divided by 3, which simplifies even further. Negative 12 divided by 3 should be a negative 4. So we know our slope for A is negative 4, which means it goes down 4, right 1. On B, same process. We need to know slope. So we have our y2 and y1 divided by x2 and x1, and in this case x1 is negative, so we minus negative. And that gives us now 4 minus 3, which is 1, 4 minus negative 2. That should give you a grand total of 6, a positive 6, minusing a negative. And that means our slope for this one is m equals 1/6. And as a slope, that means we go on our graph up 1, right 6. Up 1, right 6. So now going into our main discussion here, how to write linear equations as a function. These are the steps that we'll need to know. And again, all we're doing here is we're transforming oranges into narchies. So as we go through this, the first one, we're going to determine if the relation is a function. And to do that, we test it on the vertical line test. And we'll go over that. Step 2, we need to identify slope and the y-intercept. So slope stands for, remember, m, our variable m, and the y-intercept is the variable b. Step 3, we use slope-intercept form and replace the y with f of x. And that step's not too hard. And lastly, we identify the domain and range for each problem. So using those steps, we're going to go through and we're going to create functions from linear equations. So here we have a graph. The very first thing you need to ask yourself, is this graph a function? Will it pass the vertical line test? If I draw a vertical line anywhere here, will it pass that test, meaning it only crossed one time and only one time? And the correct answer on that one, yes, it is a function. Since it's a function and other things with that, we need to figure out where does this cross the y-axis and what's the slope? So this blue line here, it crosses the y-axis, and that number right there looks like it is going to be a 3. And then I find another place where it crosses an x and a y, which looks like this point right here. So I figure out from there, how far from this point do I have to go up and right to get to where this crosses? And that tells me I go up 2, right 1, which means I have a slope of 2. Since I have a slope of 2 and a y-intercept of 3, I now have my slope-intercept form, which is y equals mx plus b. What am I going to do with this m, and what am I going to do with this b in order to make an equation? Well, we replace the m and the b, and so I have a y equals a 2x plus 3. Now this next step, we need to convert or change our orange into a narchie. To do that, we just call it something different. Even though it's the same thing, we're just writing it a different way because it requires us to do this. And the reason for that is we're looking at it at a different perspective. So here we have replace the y equals with f of x equals, or you can even just say replace y with f of x. So to do that, I come up here and I find y, and I need to replace it, so I'm writing it down as f of x equals, and then everything after stays exactly the same. So now notice we've changed our y to f of x, and everything else is exactly the same. Now instead of having a linear equation, we have a function. Now that we've done our function, we should move on to write our domain and range. And with the domain and range, domain, how far left and right is this blue line going to travel if we were to follow it as far as it goes? And it looks like it's going to travel left forever. There will be a place where I can get to the blue line traveling, going left and down, and going right and up. It looks like there will be a place that I will cross this blue line. So to say that, we say the set of x such that x, and then how do we say forever? It's going forever. In this math language, we call forever an element of real numbers. And because this is going left and right forever, and also up and down forever, our range we just rewrite as the set y such that y, and then we already said forever here, we just have to copy that down, is an element of real numbers. Apart from that, this next example, you'll see the line looks similar. It has a negative slope, but the first thing we need to see, is this a function? Will it pass the vertical line test? And we could draw vertical lines anywhere along here. If it only crosses one time, it is a function. As we see, this one is a function. Now that we've found out it's a function, where does it cross the y-axis, and what's the slope? Looks like this blue line crosses the y-axis at -1, so I put a -1 there. And it also looks like it crosses right here, and this one happens to cross the x-axis, which makes it nice. How do I go from the red dot to the blue dot? Traveling here, I would go down 1, right 2, which means my slope is a -1 divided by 2. Using our slope-intercept form, y equals mx plus b, I can replace the m here and the b here with the numbers I found. And so I replace those. I get y equals -1/2 x plus -1. And plus -1 will give us the same thing as minus a positive. So I'm just going to change this to, instead of plus negative, I'm just going to do x minus 1. Once we found out our formula, we need to replace this equation here. We have our slope-intercept form. We replace the y with f of x, and then that will create a function. So I write f of x equals -1/2 x minus 1. Our last step, we need to find the domain and range. How far left and right will this line travel? If I'm going on this line, how far left will it go, how far right will it go? And it looks like x continues to increase as we follow this blue line. X continues to decrease as we follow it this direction. So it looks like it's going to go forever. So we say the set x such that x is an element of real numbers. And again, that's how we say forever in set notation. And then lastly, the range. How far up and down is this blue line going to travel? If I follow the y-axis, will there be a point that I can find part of this? And as you can see here, it's going up and down here. Up 1, left 2, up 1, left 2, up 1, left 2 forever. Down 1, left 2, down 1, left 2 forever. Oh, sorry, excuse me. Down 1, right 2, down 1, right 2. Which means it's constantly going down, so it will go down forever. So we say the set y such that y is an element of real numbers. Our last few examples, we need to go through and figure out some things from a table. Here we have an input-output table, and we're going to write an equation in function notation that describes the function shown in the table. So the very first thing, we need to find the change in x and the change in y. Input is always x, output is always y for our examples. And so our input, 2 turns into 4, that's a change of plus 2. 4 turns into 6, that's a change of plus 2. 6 turns into 8, again, a change of plus 2. The output, -2 turns into -5. That's a change of -3, meaning -3. -5 to 8, -3. And -8 to 11, -3. From that information, I could, as I write f of x equals, I could draw a graph here. And I could graph this first point, but then I want to figure out where x equals 0 is a y-intercept. So I go 0 and up 1 because I added 3 to this to get there. So I know where it crosses the y-axis. Then I could go down 3, right 2, which seems to be the slope here because the next point, x is 2, y is -2, and I can put that there. This takes a lot of effort though. So to show you that if I went down 3, right 2, I would have a slope of -3/2, I could write that, -3/2, and it crosses the y-axis at 1. Now graphing it, sometimes it's hard to visualize this. Sometimes it's hard to put this stuff together, especially when it doesn't give you when x equals 0. Since we were able to find that though, we wouldn't have that many issues. But I want you to notice a pattern here. -3, -3, 2, and 2. And if you remember our formula is, from here, our x and y, we have change in y divided by change in x. I could take 2 of these points, and I could subtract them, 2 of these points and subtract them, and then use division. And that will give me my slope. So now that I've found slope, I have the y-intercept. All I have to do is have this equation written, which we've already done. Same type of example, except for now we have to figure out what the missing number is. And because this says it's a linear function, that means it's a straight line. These will go up by the same rate. And by the same rate meaning from 1 to 2 should be the same as 2 to 3, and 3 to 4, and 4 to 5. But you notice here what's happening with our x values. It increases there, and I could say +1, but then from 2 to 4 doesn't go +1. So that's not increasing the same rate in terms of what we've written down. It's actually being times by 2 every single time. And since it's being times by 2, that means my rate down here is not going to be constant, or it's not going to look constant. It will be constant. And so from there, that's -3 to 0, increases by 3. I don't know how much this is going to increase by because this one's looks like it doubled. So I could think about my rate and maybe double it. But to show this, I'm going to create a table, and I'm going to count from 1, and I'm going to go probably to 5, maybe 6. And as I go through here, at 1, what's my y value? Here's 1. My y value looks like it's -3, so I'm going to put -3 in there. At 2, my y value is 0. What's it going to be if it's 3 here? If my x value is 3, and this is increasing by 3 every time, at 3, it should be +3, which makes that a 3. At 4, I continue with this same change. I add 3, and that'll give me 6. So I know this number up here, it should be 6. I could keep going and figure out other things, but that one should be 6. A quick way to do this is I take the top number here, and I multiply it by the bottom number, and that will give me my next change in my y value. Since this is doubling, I need to double the change that happens for y, and if I do +3 and I double it, what's 0 plus 6? It should give us 6. I'd prefer to set up a table to look at it. It's really easy to see what happens with these numbers, and in most examples it'll be pretty easy to set up a table. And now that we found the missing value for our linear function, we can move on. The last thing we're going to go through today is point-slope formula. The first thing on here we see y minus y1 equals m times x minus x1. We can rearrange that because we know what slope is, we know what the points are, and if we want to rearrange this to be in slope-intercept form, we would say y equals m times x minus x1 in parentheses plus y1. We'll get the same stuff here, but the nice thing about this is it's already in slope-intercept form, so we don't have to do too much work. We can just use this formula. So our first example, from this we need to find an equation of the line that passes through the given points. A 2, 3, and a 4, 7. So as we go through this, we're going to find slope. To find slope, we do change in y divided by change in x, meaning y2 minus y1 divided by x2 minus x1. And as we put that information in, we have 7 minus 3 divided by 4 minus 2, which simplifies to 4 divided by 2. So our slope here is 2. In my formula now, I need to pick my slope, x1 and y1, which you can see up here, x1 and y1, and I plug the information in. So y equals 2 times x1 minus 2, x minus 2, close parentheses, plus y1, which is 3. And then I use the distributive property to get 2 times x minus 4, because we get 2 times x, 2 times 2 is 4, and then I add 3, which simplifies to y equals 2x minus 1. Our last example, same thing. We set this one up. I need to know slope. So I set up my slope formula, and I'm able to work through this to find out my slope is going to turn out to be 6. As I get 6 as my slope, I need to plug this information into my equation, which means I will change m and turn it into slope, which is 6. I'll change x1, and that's the 4 here, and I'll change y1, which is the negative 2. So I replace all of those, and then I use the distributive property. I distribute this 6 to both the x and the 4 by multiplication to give me 6x minus 24. And before that, real quick, I changed this plus negative. I changed that to just a minus, because plussing a negative is the same thing as minusing a positive. And so now we get 6x minus 24 minus 2. And if I lose $24 and I lose 2 more, I get y equals 6x minus 26. Hopefully that was helpful for you. Good luck today. If you have any questions or concerns, let me know later. Thanks. Hope you have a good day. Bye.